Okay.
Does it say it's doing it?
Oh, by Jove, I think we're on YouTube, gentlemen. Here we go again, stargazers and astronomy lovers. It's the SBAU Astro Hour, Memorial Day edition, weekly vlog and podcast. Are we okay?
Go ahead.
Am I repeating myself?
No.
No,
We got an echo in here.
Just a momentary feedback. I had Zoom and YouTube open for a second.
That's all right. It makes me sound like God. Santa Barbara's astronomical unit, our South Coast Long-Time Telescope and Astrophysics Club using Zoom for the three of us this week and viewable on YouTube by the membership. Not sure how many are going to the Imaginary and not watching us this early morning. It's episode number 66, though, for the week of May 30th through June 5th. Today is Memorial Day 2022. I'm your MC and host, Ron Heron, Vice President of the club, the head questioner for the fascinating field of astronomy. Got the masters on the screen. We'll introduce you to the president, then I'll give you the headlines. Also doing webmaster duties on a Monday morning, Jerry Wilson. How are you? Good morning.
Good morning. I'm fine.
Your lovely wife, Pat Forgy, is
Yes.
in the house, or did she take off already doing Memorial Day?
She's out doing something.
Okay.
She's
Tom Whittemore is on the screen. Former Westmont College science instructor, married to Maureen all these years.
Yeah.
And
morning.
so it looks like it'll be the three of us, unless Bruce Murdoch or Tim Crawford, well, he doesn't have a regular link, I guess, joins us, but Bruce is still recovering. I hope he's getting a lot better from falling at one of our star parties. That would bring me to some plugs real quick. Star parties are now live, and they're probably the most successful thing the SBAU does, isn't it? That 500-600 people show up at the museum on the second Saturday, which will be 2 Saturdays away. I do want to say this coming Friday night, everybody, June 3rd, you're invited to get on board, member or not. Join us with our first Friday of the month SBAU general meeting using YouTube, at least your side of it. Our side is Zoom. Our guest speaker we got him from longtime member Joe Doyle, referred me to Dr. Ben Darvish of Caltech, whose science speech next Friday night, starting right after 7:30 when we launch the meeting, up till about 9, the evolution of galaxies. Today, going to check on Antares, the Coma Galaxy Cluster, a visit to Andromeda's little family of galaxies. I didn't know there was one. Got a variable star and a weekly nebula, planetary nebula, Aquila the Eagle, to talk about. Some really bad solar flares. I think we dodged a bullet. NASA's going to visit Jupiter's water moon, Europa, not once, but twice, see if there's life in that frozen underwater ocean. Do meteors come in colors at a quadruple star system? Wait till you see the tracks of their orbits. And on screen, and once again, Tom and Jerry. Let's talk about, let's do two stories together, gentlemen. Tonight is the Herculids. I hadn't heard of that. And then we'll talk about colors for meteors. This could be a fantastic one, couldn't it, gentlemen? This meteor shower. It's all this week. The Herculean or Herculid or whatever.
Yeah, it's a projected possible meteor shower, new one.
Okay, yeah, I was going to say I never heard of it. So
no, it's a brand new one.
Okay.
According to the talking notes from our leader here, outburst of thousands, and I did read on YouTube or somewhere I got that it may be an incredible show, hundreds per minute, if that's possible. And it's because of the Schwarzmann-Wachmann comet, or 0.73p/Schwarzmann-Wachmann, the two astronomers who found it. And it's here in North America. The Tau Herculid radiant will be high in the sky at night at peak time, 11 o'clock, no moonlight, moon switches, right? Okay, we'll just, I don't know if you want to have to jump ahead on this colors of the meteors. I don't have much here, but I do know that various combinations of elements and the speed of the incoming meteors determines, we get different colors, Mr. President?
Oh, yes.
Oh, sure.
Meteors, it's not just the chart shown here. Let's see if I can.
Yeah, call that up because we can broadcast color, can't we? Nitrogen oxide gives us one color. Iron gives us the color. I was surprised back. I thought iron would be red. That's the second one from the left, and it's not red. Red's on the left. nitrogen, oxygen. And then calcium, the third color. And
Yeah, this is just from element burning. And that's the color you get. If you took some, for example, if you have a spectrometer set up or spectroscope set up on your lab bench and you have a flame there and you dip a piece of something that doesn't burn in these different elements and get it on there and burn them, this is the color that you'll get. It's the dominant color of that element burning. And that's what you would see if the asteroid or meteor is dominated by or has a high concentration of the elements in it. But the color also, go ahead.
It's a similar process to spectroscopy?
It is the process of spectroscopy, yeah.
Oh, it is. Okay.
So this would show a strong line in a spectroscope or a spectrograph, which shows the peaks of where the different elements are. One of them would particularly dominate. The easiest one is to do it at home, and you can do this at home if you're careful. Take a piece of metal like a paper clip and dip it in some salt, lick it and dip it in some salt, and put it in the stove's gas flame. And you'll see the flame where the sodium is burning, you'll see it turn bright yellow.
Is that right? And that's how we look at stars from a great distance and tell what's in their atmosphere.
Well, it would be, but that takes a fine, high performance spectrograph to see it in stars. You'll see the whole spectrum. But when you get an overall visual effect, your eye does not break it up into individual colors. But if something dominates, then that emission line, it gives it the color. But you have to remember that at night you're looking into a dark sky with probably dark adapted eyes. And when a meteor appears, if it's a bright one, it's going to saturate your eye sensors. And so it's very possibly going to look white because of the contrast difference. Plus there's also the speed of the meteor. These real little fast meteors that you see at night, just a little white streak that goes by. That's something about the size of a grain of sand up to the size of a very small pebble. And they're traveling at very high speed and they just burn up real quick. And those look brief and white. The really big ones can come in at slow speeds. They're much larger, basketball size or bigger. And they're called bolids. And they come in, they look like they're moving very slowly. They have a long, usually reddish orange tail, and they break apart frequently. So again, they're traveling slower. The speed of the meteor determines how hot it gets. And when a meteor gets hot, it also glows by how hot it is. So it's a combination of chemical effect and how hot the thing is. This chart just shows the chemical component effect.
Mm-hmm.
Well, that doesn't mean that the whole meteorite is made of sodium or made of iron. It's a mixture, wouldn't you say?
No.
Just the part that is being evaporated.
Yeah, that's a high proportion.
Welcome aboard, Bruce Murdoch, who's still
Thank
recovering. You. Looks like he's in his recovery chair. How you feeling, our friend?
Better every day.
Good.
Well, I just learned, I wanted to tell you real quick, not to interrupt, we'll get back on the subject and get your opinions on it, but one of your members of the Santa Barbara Theater Organ Society, friend of mine named Fred Ziesenhenny, he's on the board.
Oh, I know him very well, yeah.
Oh yeah, he listens to us and watches us, and he's probably on board right now. But there's a black, there's the there's the monstrous slab that was from 2001 Space Odyssey in the middle of my screen. I don't know about yours.
I've got it too.
Okay, there we go.
Well, that's the whole screen.
Turn off share screen when I'm bringing something else up.
What was that called? The monolith?
Yeah.
Right.
All right. Well, Bruce, I don't know. You got in on the end of that, but starting tonight, I guess, and maybe all this week, a new Herculid meteor shower. Have you ever heard of the Herculid radiant?
No, I haven't. The clear sky chart for tonight isn't very favorable, though.
Yeah.
Well, the seeing is poor.
Oh, cloud cover, May gray. Yeah. What do we got here, Mr. President?
This is a graphic from the website. The website that's called Astronomy by the Bay. And the bay in this case does not refer to San Francisco Bay. It refers to something in Massachusetts. And they had a nice graphic on the Tau Hercules, a projected new possible meteor shower, the newest meteor shower, 2 question marks. And this, the radiant is way up here, but of course you'll see meteors all over the sky. This is for tonight, 5:30 at 23 hours, so 11 p.m. And the, let's see, where do I get that? Okay. Now.
So Jerry, is that radiant near the keystone? Where is Tau
That's in
Hercules?
the keystone.
Okay.
I'm sorry, but I don't totally understand a radiant. It's one spot. Now, what if the comet went by us? Why wouldn't it leave a trail? It would come from a big long line across the sky.
It would leave a trail, but all the trails, if you took a photograph and you sat down at your desk later with a ruler and you drew all line for all these trails, they'd all appear to come back and converge at one point.
Really?
Excuse
Okay.
me while I have a sip of SBAU coffee.
Bruce, for your edification, it was 73P Schwarzmann-Wachmann. That was the name of the comet we all missed. We hadn't heard of that either, have we?
The
No,
comet is disintegrating, and it's up to 70 pieces now. So they're projecting that with this split up, there's going to be a large number of small pieces that will be meteorites, and we are going to pass through the orbit of that comet later tonight and possibly into Tuesday.
Do
So
we
they're
know
telling-
do we know when it came and went?
The comet is already, you can see it in the sky with a telescope. It's broken up. You can't find it so much anymore. They're tracking it. It's being tracked with large telescopes.
Going back out to the Oort cloud.
Now these are going to be slow speed meteors. They're traveling about 16 kilometers per second. So that's not very fast in terms of meteors. So they should be give you a chance to see them. We don't know the size or anything. The forecast peak time is around 11 p.m. tonight.
Okay.
Is it technically the same thing as burning when it hits the atmosphere? It's a plasma thing. I know it affects our incoming space probes and landers, but my question is based on the fact that the Cassini probe was dropped into the Saturn atmosphere and it burned up. And I got to think, is there oxygen in that atmosphere?
No, it has nothing to do with that meaning of burning.
Okay.
It's just that it hits the atmosphere and it's traveling such a high speed that friction, the air molecules, heats it up. And then as something heats up, it melts, part of it melts off or breaks off and streams back. And so it leaves a trail of bright sparks following it. Back in the 60s, I was exiting the science building at Cal State Northridge. And without really knowing what it was, we witnessed a large satellite re-entering the Earth's atmosphere in the south, and it was very spectacular.
Wow.
So,
since it's entering our atmosphere, which contains oxygen, does it not burn?
if there
In other words, it makes
is
oxides
material,
of the metal.
Yeah.
Say again?
if there's stuff that will react with oxygen, which is just about anything, it will also burn that way too. But the primary heat is due to friction, and the thing heats up past red hot to white hot.
And that's called plasma.
Yeah, all of our spacecraft, the Dragon capsule to the ISS and the Apollo lunar module, or the capsule, all those things, when they re-enter the Earth's atmosphere, they all heat up and produce this meteor-like trail. Now, do you know what the mechanism they use to cool that off? When it heats up from the outside, how do they cool it off?
Well, special ties or tiles on the space shuttle, but I don't know about the
Yeah,
other.
Space Shuttle has tiles to resist the heat, but the Mercury, Gemini, Apollo had heat shields, detachable heat shields, and they cool by ablation. That is, the material is a very low thermal conductivity material, so it confines the heating to the very outer surface. But as soon as the material gets hot and melts at the surface, the part that's hot falls away. And so it takes the heat with it. So the friction has to start all over again and heat the next layer down. So that's called cooling by ablation.
How is the word plasma defined? Is what's going on in the sun and virtually all stars and what's going on?
If atoms do not have electrons, they're plasma.
I've heard that's the fifth. Is it the fifth or the fourth? No,
Fourth.
the fourth form of matter is plasma.
Right. Yeah.
Okay.
It turns out most of the universe is plasma, and only a small part of it is solid, liquid, or gas.
Was it possible that debris from those comet tails could be so slow they would just gently float down, hardly hit the atmosphere at all?
That would be low probability fortuitous thing, but they just after it burns up, and parts flake off and they cool down, they fall to Earth if they're small enough, and they burn completely. They fall down as ash.
I see. Okay. I suppose
Part of the 10 tons every day that hits the Earth, right?
Yeah.
Well, this is supposed to be a magnificent meteor shower if it bears fruit. It starts tonight?
Yeah.
Okay.
Look like tonight, tomorrow night, huh, Jerry?
Yeah.
Okay.
Mr. Whittemore, formerly with Westmont College, editor of our incredible newsletter.
Yeah, I just finished the newsletter, and thank you, Jerry, for your article.
Okay, good.
What's it about? What did membership look forward to him talking about this time?
I hope they look forward to my crazy captions, but also I started a little column in May called Star Stories. In the particular Star Story in May, it was all about Arcturus. And some of my motivation is to, if you're new to the science, one, find out where these things are in the sky. Okay. So I always give guidance to that, and I always have a little map. The other thing is it tells the story about the evolution of stars, just very briefly. Okay. So I found it interesting to do Arcturus because Arcturus is a 7 billion year old star, which means that it's got 3 billion years or so on our sun. It's also going to fade out basically into a white dwarf, just like our sun will in some, billions of years. So when you show people Arcturus, which is the bright red star in Boötis, the herdsman, you can tell them that this is what the sun will look like in about 3 billion years, when basically it's pretty much enveloping, not only Mercury and Venus, but also probably our planet. So in contrast to that, instead of arcing to Arcturus, I spiked onto Spica. So the story for the June issue, which I just put together yesterday, is all about Spica. And for me, it was interesting to find out that Spica is actually a double star. I didn't know that. So maybe Jerry knew that, but the two companions are very, very close to one another. And so it's nearly impossible to see the other one basically visually. Okay, I think they actually see it. First of all, Spica is about 10 solar masses. And so another contrast with Arcturus is this thing will not fade into a white dwarf. This thing will actually explode as a supernova. Okay. The other thing is it's not 7 billion years old like Arcturus. It is only 12.5 million years old. So it's blue, white, it's a giant. It's still crafting elements in its core. It's on the main sequence. So there's this, what I'm trying to do here is give these little stories so people can appreciate what they're seeing in the sky, where the thing is, and also give a little bit of take on how stars might evolve. So that's the whole purpose. It's just been a lot of fun to start this thing. And so now you get Spica. And Jerry wrote a nice article from the president So that's in there. The outreach is starting to climb. So Chuck had quite a few candidates in outreach for the month of June. And I had some funny captions that you'll see on some pictures that Tom Totten took. Tom opens up the issue. Tom Totten actually opens up the issue. He doesn't know that now, but he gave a special viewing. I think it was on the eclipse night when most of the club was out at the marketplace. And so he gave a special outreach to 10 people. It was a private thing. And so it looked like he brought his large Dobsonian out to show them. I believe he's probably showing them the lunar eclipse. Okay, so he's featured on the front. I always like to do a picture about outreach on the front. I always like to do that. And so Tom's been taking some amazing photos over the years, and he always manages to take pictures of people in these oddball expressions, which just it leads to some fun caption writing. Okay,
Sure.
Some really caption writing.
I look forward to reading that.
Yeah, it's neat. Yeah, Spica. So Jerry, did you know that Spica was a double?
I did.
Oh, you did? Okay.
Let me show you a couple of accidental astronomers here.
Okay.
See that?
That's
Okay.
a good.
Two guys are laying out there. Let me see. I wrote all this down. Yeah. All those stars, the guys are laying out there on the campsite, looking up in the dark sky. Look at that, Charlie, or actually his name is Dale. All those stars, what do you think it means? And the other guy says, it means somebody stole our damn tent.
That's a great one.
I've seen that before, but it always makes me laugh. Yeah, we forgot about, there was another one about, let's see, the long trial. Apparently there's nothing but symbols in the courtroom. Can you call that one up? Let's see.
It says, will you identify
Long
yourself
trial.
as a spy?
Yeah, Pi is on the witness stand. Looks like ampersand is the judge. There's a question mark that is questioning him. And in the jury box, all kinds of mathematical symbols and punctuation marks. And the attorney says, please state your full name for the record books. And the Pi replies, certainly, 3.1415464218056917243098. Its trial is still going on. He's still telling his name.
That's a good one.
Oh, no, that's a good one. And Tim Crawford, our telescope expert who may be watching us, listening, like that one. What's your article about in the newsletter, Mr. President? What did you talk about?
I just recapped our last the business meeting of May, where we decided that we would try to have a hybrid meeting for our first in-person meeting of the club, the first Friday of the month of each month in Farron Hall on the museum campus. And that means a hybrid meeting means that the some of us will be in the room per usual. I don't know about the speaker for that meeting or not yet, whether he'll be there, but then other people can watch it on Zoom without having to come to the museum. And this is all contingent on COVID staying under control. We have a big spike, then we'll just stick to a Zoom meeting.
We're talking about the August meeting that we hope to be
August, first Friday in August.
Well, I sent a summary to Charles Schuler with a copy to Chuck. And the thing that is really disappointing, you go to National Beals House and you can get the statistics for Santa Barbara County. Only 66.6% of our population is vaccinated at all. And I won't go into the details, but by the time you get to how many people have had the second booster shot, I think it's like 12%. It's abysmal. And the infection, there are seven variants to the Omicron virus. And the infection rate is again starting to go up. Each time, people get over it, they get a new variant and boom, it starts to go up again. So
here's hoping it stays down.
Say again?
Here's hoping it stays down. If it spikes,
well, that's not what the graph is showing. The graph has a
Okay.
positive upslope right now.
Yeah.
Well, I got to
Yeah,
tell you, that evolution is really high speed in the microscopic world, isn't it?
yeah.
Mhm.
A lot of generations pass by.
What if we humans morphed that fast and a baby was born with a third eye, and there'd be a whole new human being with a third eye from now on, or an extra finger or something?
Oh, we do have a third eye. It's called the pineal gland.
Oh, yeah, that's right. Well, real quick before I go into the next subject, Bruce, obviously you're recovering, so the status of your theater organ society is still on hold, thanks to that.
No, actually, it isn't. We had an open console. I believe it was last Saturday.
Oh, you did.
25 people attended.
You couldn't make it?
No, I was laid up in the hospital. But we're starting up our monthly open consoles, typically the second Saturday, unless there's something going on in the theater. So you have to go to our website, sbau.sbtos.org, or call our hotline, which is 685-9891.
You know, there's nothing more moving to me than that darn huge organ in the Arlington. You just don't hear it enough. They don't have programs booked in there.
It's fun to play too.
Why doesn't some church book that place and have the most incredible music in the world? They could do Bach and Handel. And gentlemen, I'd like to talk about, if you feel like it, since Tom Whittemore sort of brought this up, talking about a double star, we have a quadruple. There's four, and I'm trying to find. Wait till you see. Can you call up some of the pictures on this while I find it before I wrote it on my little? I got it all. Your whole talking points is on one piece of legal paper, and it's quadruple star systems. They just discovered one of the youngest and closest to us quadruple star system. The outer pair orbits the inner pair. So they're spinning over here and they're spinning over here, and the two spinners are going around each other. And I didn't understand how the outside one could go, let's see, faster than the inside one until I saw the picture. Let's see, it's a Subchandra-Sekar type 1A or IA supernova. And
these are not supernovas yet. These are stars that are all below the Chandrasekhar limit, so they will not by themselves become a supernova or a nova. They will just give off their low mass stars like the sun. So they will each end, if left alone, they will each end as a planetary nebula. But these stars are so close together that they can actually shed material from one to the other, and so it can boost the mass of one star so that it actually ends up being above the Chandrasekhar limit, and then it will become supernova. So what they're looking for, what the spark this study is, there's a lot of 1A supernovas, the main type, and they've been able to, you can look at the light curves from them, and you can pretty much tell by modeling the stars what it started with and how to fit that curve. But some 1A supernovas do not fit the theoretical curve for just a star that's above the Chandrasekhar limit. So they're trying to figure other ways that a supernova could occur for stars that are below the Chandrasekhar limit, like this star, this set of stars. And some of them, like having a white dwarf next to a gas giant, and it pulls the material off of the gas giant because they're so close together. And then eventually the white dwarf then blows up and becomes a nova. So similar things like that. Here they're modeling this system. The outers, they go around the common center of gravity, which is right here. The outer one is moving slower, as they always go for the farther one out. The inner one's moving faster. This one looks like the inner one to me. This one looks like the outer one. So, they're going around a center of mass right here. And these stars have been modeled and projected, and the research team feels that it's as likely to produce a 1A type 1A supernova.
That'll happen in the future.
Yeah.
Could any of these stars have planets somehow around them?
That's a good question. I think that if stars are fairly close together, what do we have as the spacing?
Okay.
Let's see.
They may have gobbled up their planets a long time ago.
Either that or the planets are far enough out that they rotate about the common center of mass of the two stars.
Well, for the record books, it's called HD 74438, and it's 475 light years away. Discovered back.
Rolls off the tongue there, but yeah.
Okay, it's discovered back in 2017. Group effort from Gaia and ESO, European Space, in South Africa and New Zealand. They saw it with those telescopes. Whatever you bring up, I'll try to match it.
This is one star set orbits each other on 20 days. The other one orbits a good 4 days. So these are very close together, and I would say that planets trying to, or in that any system like that would have been thrown out a long time ago. That to me, it doesn't connote a stable system. Bruce is more expert on that.
When we gave our presentation, a year
ago,
2 years ago in December, about modeling, Farshad Barman did exactly model planets around a two-star system, and the planet orbit it keeps tilting, and so over time it keeps just tracing a new orbit. In other words, it doesn't follow the classical way things go because of the two stars.
What if you gentlemen focused in on this? Would you see 4 stars, 2 stars, or 1?
No, these are spectroscopic binaries.
Okay.
The conclusion of their study, interesting on this particular star set, but they claim that they believe that, or their study shows that between 70 and 85% of all type 1A supernova could be due to mergers of star systems like this.
But they have them as many as 5 or 6 or 7 can go around each other, can't they?
I don't know of any like that, but we have discussed a sixfold star system before. Yeah.
Wow.
I've forgotten either Alcor or Mizar has 6 stars in the.
Yeah, one of those.
Yeah.
I have a big black bar across my screen.
Yeah, it's the monolith.
Again.
There we go. Okay.
There we go.
Well, there's some fascinating stuff you put in your talking points this week, Jerry, like mapping a neutron star's surface for the first time.
Yes.
You want to go there? Called the Universal Lighthouses, or Universe's Lighthouses. Tiny, compact, very heavy objects are the remains of one massive star that are spinning quickly, beaming radiation out into space. Is our sun going to become one of those someday? It's going to become a white dwarf.
It's going to become a white dwarf.
A white dwarf that does that is suddenly a neutron star, or is a neutron star a different animal?
No,
it's not.
White dwarf is the end stage for stars like our sun.
Okay, first time ever we've focused in on the very surface. How did they do that? A 16 wide pulsar neutron star on the outside of the ISS, the space station.
Yes.
An instrument called the NICER.
Now this simulation is the result of computer simulation or data reduction. They did not resolve a neutron star and take pictures of it, but you can get information out of an object that you cannot resolve if it's moving, like rotating, because it changes brightness in a certain pattern, and you can model that brightness change by how you place different sample brightnesses on the disk, and you can determine its rotation period. These are 2 different interpretations using software from 2 different research groups. They're quite similar. The major difference is the size of the little crescent arc at the bottom. So the rest of it is in fair agreement with each other. The neutron star is radiating along its magnetic poles. It sends out these beams along its magnetic poles. The magnetic pole does not necessarily line up with the rotational pole. And you see that here. So they had always thought or just assumed, because they've never actually reduced the data from one, that you would see a spot, if it were tipped away from us, you would just see a stationary spot at one pole as it rotated around. And then there would be another stationary spot at the other pole. But the data that they've reduced is consistent with a more complex pattern like this. And this is the source of the gamma rays that come off, or X-rays that come off of the neutron star. They come off with sources like this, and it's due to the shape of the magnetic field of the neutron star.
Wow. So it's got iron in it?
It's got, I don't know what the meaning of it is. It's got iron nuclei in it, but everything's mashed together.
Oh
So,
yeah.
you know, it's
just
not
a soup.
real. Yeah, it's the electrons have been forced by gravity into the protons, and they have all become neutrons. So the entire thing is a bunch of neutrons. As that's a very simple view. What it actually is inside, we have no clue, except to say it's just neutrons. Whether it's a fluid or a crystal or yeah, I'm not able to find any research that sheds light on that.
Well, this sucker is called the JOO30 plus 0451. It's 1,100 light years away on Pisces, published by the Astrophysical Journal Letters. But I swear, to be able to determine that, it seems to me what you just showed us could have been taken by the Webb, but it's really not up and doing that yet. How in the world?
This is in X-rays. It won't be visible to the Webb, which is looking in infrared.
Oh, okay. This is X-rays.
Yeah.
Okay.
So this neutron star has about 1.3 to 1.4 times the mass of the sun, and it's 16 miles in diameter.
But if it were spinning with the two, one on the north of the two beams, is that the X-rays you're talking about, or does X-rays come off the whole thing in all directions?
So X-rays only come off in a pattern defined by the magnetic field.
Okay,
it's a lot like sunspots.
Okay, but not enough to hurt us. If it
if pointed directly at us and close enough, it would wipe us.
Yeah.
But the chances are that's very, very remote.
Okay, if it's not spinning and not sending out the waves, it's just a neutron star. If it is spinning, it's a pulsar that happens to be a spinning neutron star, right?
Right.
Definition. And a white dwarf is a different animal.
The image that I heard when I was studying in college is you take a big styrofoam ball and you jam a flashlight in it, and then you spin the ball, and as the flashlight goes around, it blinks. You know, you see it blinking, and there'll be one. So
what I don't understand about those spinners is sometimes they're going hundreds of times a second.
Yes, very fast.
I know, and yet if they're 16 miles across, that means that any point on the surface that's going hundreds of miles a second are probably going close to the speed of light.
Some of them apparently are.
Man,
we don't know what happens with the matter when that's in the configuration. But it's later. The classic example is like a skater, and when she's got her arms out, she's spinning, and as she draws her arms in, her moment of inertia changes, and it spins her up faster and faster. Well, as a star collapses into a neutron star, that spins it up. So they go very fast because they're very small. They started very big.
Well, I don't understand how they get a magnetic field if it's all neutrons, because protons are positive and electrons are negative, and suddenly it's neutral. How do you get magnetism out of that?
You take that doesn't, neutrons have magnetic fields. That's okay.
They do.
You can take an electron and smash it into a proton, and with some other stuff you get a neutron.
Wow.
And the thing that pushes them together is extremely strong gravity.
Do these suckers go on to become black holes?
Um, no, I
No,
don't.
no, they just stay
Yeah, I
neutral.
don't believe no.
But they
They
used to
lost
be,
their chance. If they had a bigger mass, they would.
okay, but
Or
they used,
a bigger event like a nova.
oh, well, they had a nova, didn't they? That's what's left behind after they blew
No,
up.
no, this is after. This is this is not a black hole. It was not a nova. This is below the Chandrasekhar limit. Matter of
Different
fact, these look like they're calculated right at the Chandrasekhar limit, about 1.3 solar masses.
Wow. Fantastic stuff. We have a variable star of the month and what I'm starting to call the nebula, planetary nebula of the week. The variable, this is a whole class of stars that I didn't know about before I joined the club. Y Canum Vernaticorum. Vernaticorum. You guys know how to pronounce these things.
Yeah.
Certainly, Chuck does, and Chuck is on assignment this week.
Venaticorum is correct. Venaticorum.
Venaticorum, okay.
It's plural possessive.
Apparently there's an association, I don't imagine we're members of it, American Association of Variable Star Observers. Are there as many up there as there are binaries? Or not quite as many, perhaps, but they dim and they get brighter. And this,
Yeah.
is it
For-
why? Is it
For a
why?
wide variety of reasons.
Oh, okay, but it's also called La Superba, which means the magnificent in some language. What is that, Spanish?
Yeah.
It's got a deep red color due to carbon.
Oh, it's in Italian.
Oh, it's Italian. Okay.
Either Italian or Latin.
Yeah.
That's where we got superb from.
Yeah, it's the Italian astronomer Angelo Secchi.
I love it. Okay. Well, apparently carbon in this case makes it red, not iron. Interesting. After dark, look east, then almost straight up to Canis Venatici. That's Italian, the hunting dog.
No, it's not. It's Latin. Canes is dogs. Venatici, hunting. So it's hunting dogs. And the possessive case is canum venaticorum. Straight out of Latin, straight out.
Connie, okay. Well, there's also a magnitude 3 alpha star called Cor Caroli. Am I
Yes.
right?
Beautiful star.
7 degrees northwest to find it. Changes brightness over 160 days from magnitude 4.8 up to magnitude 6.3, which is actually down to
That's dimmer.
Yeah.
I showed that to the public at the April outreach at Westmont. Cor Caroli, Charles Hart.
But there are different reasons for these stars being variable, dimming and brightening, aren't there? Or they all go on the same. You called it Cepheid variables. That's a type, isn't it? In your talk, Tom.
That's a certain class of variable.
Okay.
Yeah.
Well, I don't know if we had pictures with us, but it's ended up by saying it's a semi-regular variable, whatever that means. So
Let's
we'll
look
get
at the
some
chart.
photographs.
Let's see the chart.
This shows it tonight at 11 o'clock from here. The red bullseye is the star. You can see a lot of other names for it over here. And let's see, there's Ursa Minor, the Little Dipper.
Mm-hmm.
And this is Coma Berenices, of course.
Mm-hmm.
Virgo is over here, and Leo Minor and the Big Dipper here. So it's in the curve of the Big Dipper. So it's an easy star to spot up here because it's it's a circumpolar star, so you can find it probably almost any time of year in the northern hemisphere.
What curve?
What's that?
What curve in the Big Dipper? In the handle or in the cup?
Handle.
Oh,
Yeah, see the handle of the curve. This is the Big Dipper here, and then there, and there, and there. And this particular planetarium program they feel compelled to add a line to cover every star in the constellation. But the thing I always think of is just this part of it.
I gotcha.
Okay.
Fantastic. Variable star of the month. So we may talk about it again later on. But right now, our planetary nebula of the week is Aquila the Eagle. Sounds like a Saturday morning cartoon. Also called NGC 6781, the 22nd in size among the 88 constellations. We have an eagle up there as a constellation?
Yeah, Aquila.
Aquila. Okay, it's not Spanish style Aquila. All
So
right.
that is straight from Latin.
No Messier objects within it. Emission nebulae, they're called. NGC 6781 is a great target for amateurs, lies 3,500 light years out there, and is 2 arc minutes light years in diameter. That's still considerable. Its bubble continues to expand, will do so until it is too far from the central white dwarf for the star's radiation to ionize it. It'll slowly fade away. And
this shows, can you see this okay?
Mm-hmm.
can you enlarge it?
Yes.
Ah, there we go.
This shows the Milky Way.
Oh, yeah.
The target here is the planetary nebula. This is the constellation of Aquila. And these 3 stars are what I can pick out by eye. And I don't see all these other things when I look. But it gets you in the area, and then you can set up. What I do if I want to find it without using my go-to system is I'll find a series of stars in a star chart the night before or the day before, and I'll figure out a star hopping technique to get to it, find it. But nowadays, everybody tends to use their go-to system and lose familiarity with the night sky, unfortunately.
Is there a name for that band that we see that represents the interior of the Milky Way? What do they call that? Just the gas cloud?
The Milky Way.
The Milky Way. Well, I've always wondered if there's anything that's special up there that's right on those clouds, and this appears to be one of them, or the only one I know about anyway.
It's also a tasty candy bar, Ron.
That's right. Wait till we get to the Andromeda family. I didn't know Andromeda.
This is the planetary. This is the picture taken by Adam Block in Arizona. So it's quite a nice little system. Very well photographed and processed here. Nice dark sky.
Okay, for the benefit of the viewer that doesn't know what the heck planetary means, can you explain that again? It doesn't involve planets.
No. It's basically a white dwarf shedding its outer atmosphere, okay? And the white dwarf is so hot, often 100,000 kelvins, that it basically causes, emission in the gas. And so you see this is a beautiful shot by Block. I'll bet you he shot that through the 61 inch up in the Catalinas above Tucson. That's my guess.
Now, we're not looking at a disk flat on. We're looking at a blue central orb, if you will, with a red outer or
No, that's burped atmosphere, Ron. As Chuck likes to say, it's a burp.
It's probably a spherical bubble.
Yeah.
Okay. Meaning we're looking through the red to see the interior. Well, anyway, I see blue and red. But this was not a hypo or a nova, supernova, right?
Oh, no. It's a white dwarf. It's the fate of our sun. My guess, I don't know this for a fact, is that the blue that you see there is probably oxygen 3 line, and the red that Block just delicately laid out, probably hydrogen, be my guess. I don't know what Adam did to do the coloring, but it's a gorgeous shot.
Yeah.
Well, how did it get rid of its outer layers then if it wasn't a nova of some sort?
It collapsed. It came to the end of its fusion cycle, and the outward pressure that was fighting gravity to maintain the size of the star, that outward pressure stopped and gravity won, and it very rapidly compressed the star and caused it to rebound and blow the outer layers off.
Right. So the gas is now free to roam.
Right, and contribute to new stars.
Yeah.
Now, planetary nebula is called that because earlier on, when in visual astronomy, they would find these nebulas with early scopes that were not the best scopes in the world, and they looked like the small disk of a planet, and they couldn't tell the difference. So they just called them planetaries.
But the stuff that it's sloughed off during that big transition, we don't see it. It's not.
Yep. No, that's what you do see. That stuff that's sloughed off.
Oh, that's okay. So in the middle of that, we can't really see it with even a telescope, let alone a naked eye.
No, you can. You can see
I think
the,
you can see the
central
central,
stars right there.
yeah, that's the central dwarf, Ron.
Yeah.
How big do you suppose it is, a white dwarf? Like a neutron star, 16 miles?
Oh, no,
About this.
about Earth size.
Go ahead.
I just say roughly Earth size, right, Jerry?
Oh, and it's most of the stuff in the old star, at least the heavier stuff, perhaps. Okay, I'll buy that. And that's a
Yeah, I
planetary.
mean, stars like this, Ron, they don't have the chance to make heavier and heavier and heavier elements.
Right.
Probably only crafted out to carbon, maybe some nitrogen through what they call the CNO cycle, the carbon, nitrogen, oxygen cycle.
We lost Bruce. Well, interesting. Aquila, the eagle, is out there.
Mhm.
Our sun, let's bring it back home, burped. Let's had some solar flares. Were they dangerous? Happened in October, several months ago, last fall. let's see, AR 2192 is the solar active region. That's what they call it. And according to your talking points, Jerry, it was the largest recorded sunspot activity group of the past 24 years, facing Earth, no less. Sun
Wow.
at the end of October. There we go.
Not exactly facing Earth.
Oh, not. Well,
This was taken. Yeah.
Would be in deep caca if it was.
This was taken in October 2014.
Okay.
Oh, okay.
So, and this is in the ultraviolet.
Mm-hmm.
Yeah.
So there's a lot of activity. It shows very well the magnetic, the photosphere of the sun, which is the part you see on the surface, and then the atmosphere of the sun, which is about 400, at least 400 times hotter, and the twisted up magnetic field lines, because of flows in the plasma, they lift out of the solar surface, and that you see that they're continuous lines. Unlike electric field, magnetic fields do not start and stop on an object. They are loops of everything. They are continuous loops. And this one, they have extended out of the solar surface. And when they get into the solar atmosphere, which is very hot, the magnetic field line aligns the atoms in the solar surface. And that slight alignment is a cooling. And so it causes the stuff to fall back to the sun. So the lines move up as the magnetic field lines pull out. But as it touches solar atmosphere, the solar atmosphere falls back down to these suns, to the sun's surface. As the stuff goes far enough out, like this, then it can break off. The loop can break off and form a new loop that's free of the sun. And then when that happens, that releases a lot of energy, and it throws the magnetic loop along with all of the material that's collected out into the space as a solar mass ejection. And this looks like that's happened because I don't see anywhere where this one is looping back down to the sun. So these may be some broken and reconnected magnetic field lines. That's what carries the crap to Earth.
Okay, do all sunspots end like that?
All sunspots look like this. They usually form in pairs with different polarities. This might be north, this might be south. So wherever this line goes and ends up, it has to be the other polarities that goes through the surface. But some of them are very long. Some are over here and the other parts over there. The sun is like a big string ball full of all these magnetic fields all winding up and twisting up. Because, the sun rotates at different speeds. It doesn't rotate at one speed. The equator rotates faster, the poles rotate slower. So that twists these string lines up inside, and they get all gnarled up, and pretty soon they just break and reconnect, and that releases energy.
Huh.
Hey, Ron, just to give you a feeling how fast the sun rotates, and Jerry's right on the money. It's in the equator region. It's about a month. It's about 27 days. And it gets slower and slower as you go towards the poles. It's more like 36 days up on the poles. Okay, so like Jerry said, you get all this twisting physics, okay, to basically draw these magnetic field lines one into the other and cause all this chaos. So, hey, Jerry, do you happen to know the wavelength of the X-rays? Are they soft?
Yeah, it's in the talking points. Let me see if I can get that.
Oh, okay.
You don't have to. I got them right here.
Okay.
Let's see. We're talking.
Because when I was at the Lockheed Research Labs, this was the research that we did.
The Solar Dynamics Observatory recorded 3 different wavelengths of extreme ultraviolet light, 193 angstroms in blue.
Yeah. So we were at 171. So we imaged the sun at 171. So these are what I would call EUV, extreme ultraviolet, or very, very soft X-rays. Yeah.
Well, and the other 2 are 304 angstroms in red, and they didn't give a third. But interesting.
171 angstroms.
Yeah.
What's an
So
angstrom?
193, 171, and 304.
Yeah.
Oh, okay.
I still, Jerry, maybe like you, I still think in angstroms.
Yes, I do too. I'm calibrated in angstroms. I have to pause for a moment to get to nanometers.
And you have 10 fingers available, right?
Am I the only one that has the 2001 monolith on the screen again?
Oh,
No, I've got it. I can see it too.
Okay.
That's just a gorgeous image of the sun in soft X-ray.
You know what you two just told me about the sun orbiting different speeds at different
Rotate.
levels. I've seen that on rotating, not orbiting. Yeah, I've seen that, believe it or not, on the largest planet. The clouds in bands, some of them will go faster than the others.
yeah, it's turbulent flow in Jupiter.
Oh, right.
Yeah, Jupiter. Interesting. You know, we got time. If you want to talk one more time, this is kind of big and it's last minute, but it's breaking. NASA is going to go out to Europa. They have what's called the Clipper, and they're going to go in 2 years, 2024. A robotic spacecraft going to be launched to one of the Galilean moons, I guess the smallest in Jupiter. Europa. Is that the one that was in 2001? That's
all these others are yours, but stay off of Europa.
So we knew even back in the 60s that it had a subterranean ocean. And so they're going to somehow land on that ice. How are they going to?
Yes, those cracks that you see and the colorations in the cracks are apparently clay-like minerals that are brought up from the liquid ocean underneath. So there's a lot of communication, they've decided, between the subsurface ocean and the surface. The surface is very young and smooth. It's frozen over. So there's a lot of water that comes up. And so there will be the Clipper, or what is it, the Europa Clipper, will photograph it and make measurements as it orbits Jupiter but its focus is on Europa. And then there will be the Europa lander that will land on the surface, and they're hoping to find areas from the Clipper where there is surface water freshly laid there, so there'll be like slush. So they don't, originally back in the 90s, there was a elaborate plan for what was called JIMO, the Jupiter Icy Moons Orbiter, and a lander that was going to land a nuclear reactor on the surface of Europa and melt its way through the ice into the ocean below, trailing an antenna behind it. And that was very expensive, and it got redone and redone and redone. So this is one of the less expensive offshoots of that. And rather than drill through the ice or melt through it, they're hoping to find fresh ice or slushy ice on the surface that they can do their life test measurements.
Find some microorganisms in the water.
Yeah, mostly minerals that could support life.
Oh, the whole damn thing is one giant Marianas Trench, isn't it? It's probably hundreds of miles deep.
Boy, I think it's, I don't know, miles. The outer layer is probably miles thick.
They think there's a solid core?
I don't know that. I think that's projected to have a rocky core. The interesting thing about it is that from previous probes, Europa has a magnetic field of its own. And that means that there's something that's fluid inside and it's a conductor, or it's just a conductor. And saltwater ocean will do that. So they're basing that and their estimates on the magnetic field, from the magnetic field, on how thick and how much water there is under there.
Do you think it would be salinated, salty?
Probably very mineral rich, salty, yeah. You have to have a convincing argument to talk NASA out of spending billions of dollars to go there. So they have a lot of data that's what is it, circumstantial.
Except that I don't know what's the difference between the Clipper, the initial one in the 24, and the lander. Aren't they both going to land, or is one going to orbit?
The Clipper is an orbiter.
Oh, it's an orbiter. And then I didn't understand that. And it looks like the surface of Europa is similar to the first surface of Mars. It looks like it has canals on it. Those are cracks.
Oh, yeah.
Those are cracks in the ice, aren't they?
Yes.
Give or take.
And they're cracks that are formed by ice on a liquid surface.
I wouldn't mind being on that mission, but except there aren't going to be no people. We're going to somehow find out what it sends back, I guess.
This would not be a good mission to go on. The radiation level around Jupiter is really quite high.
That's what I said. Then I don't want to be on this mission. What the hell am I saying? Bruce is back, and we're going to say goodbye to everybody and happy Memorial Day, and see everybody on the screen 7:30 this Friday night. Watch on YouTube. Dr. Darvish will talk about the evolution of galaxies now that he's over his COVID bout, which made him trade with our other guy for June. But nevertheless, second Saturday, be at Star Party. We'll have a board meeting earlier, I guess, outside the observatory. Gentlemen, take care of your lovely wives and lives, and try not to break the speed limit in those Teslas, or at least one guy on this. All right. We'll see you next week. And thank you very much. Every Monday morning, number 66.
Bye.
Okay, bye-bye.
Happy